I want to talk a little bit about a unit operation we call distillation, and you heard about that in one of the videos about production of gasoline, diesel, and so forth. Just a couple of quick clarifications and some additional explanations, as it were. So a very key unit operation in chemical engineering is distillation. And what distillation is to put it very simply, you have a column, cylinder as it were, and then we introduce crude oils, for example, here. Of course, we heat the crude oil in some way, use heat, right? And then we introduce the crude oil into this column. And what happens is, of course, the column is now heated in some way and cooled at different locations. And there are ways in which you can monitor the column with temperature sensors, pressure sensors, and so forth. The important thing that I wanted to explain here was that in crude oil, it is going to contain hydrocarbons, as you can see in some of the videos. You know, you have going to have propane, butane, octane, so on and so forth, right? So crude oil has hydrocarbons with small carbon, few carbons, and larger carbon numbers. What is important about this distillation operation is the distillation column separates the components according to essentially the number of carbon atoms. The slight differences, of course, sometimes there are components with a certain number of carbon atoms that are not as quote-unquote heavy as the same type of hydrocarbon, the same number of carbon atoms but have a different structure. But the important stuff is that as you go in the top of the column, you get fewer and fewer carbons, if you will, as you go from the bottom to the top. So the heavier hydrocarbons are actually recovered here, and the lighter hydrocarbons are at the top. At the very top, you may actually even see some gas, natural gas, right? And so, if you remember, there are some tables in some of the videos that talk about gasoline and diesel. Gasoline, for example, typically C7, C8, C10, and so forth, right? And diesel has slightly higher molecular weights. So essentially, if I find diesel over here in the column, my gasoline actually will be found in will actually separate at a location slightly higher than where diesel is actually separated. The other thing to remember is that there is no such thing as one stream coming out that has, say, diesel or gasoline. At some particular location in the distillation column, you're going to actually have a mixture of these hydrocarbons come out. And so they're going to have a mixture property that will be like, for example, a hydrocarbon with a certain number of carbons here, with gasoline with this slightly less number of carbons on the average and so forth. So the important thing about distillation is heat, and then based on the thermal properties of the hydrocarbon, they separate in the distillation column according to how heavy or how light they are. And so we essentially can capture different types of hydrocarbons at different parts of the column. Just to give you a simple example. So if I have a heavier set of hydrocarbons over here, and if I want to convert them to a smaller set of hydrocarbons, if you will, smaller number of carbons, I may take a stream from here and say take it to another unit called fluid catalytic cracking, and then that will take a heavier set of hydrocarbons, convert them to lighter set of hydrocarbons. So when you're looking at a distillation column, because this is highly simplified description, important thing is that as you go from the bottom to the top, the molecular weight, the size of the hydrocarbons goes down. Just thought I'll add that in there so to help you understand the important unit operation of distillation, which is used to create the fuels, gasoline, and diesel.